Wait, I'm like, can you do it? No. Can you do it? Oh, come on.
Hello, everyone. Please try and get seated if possible. If not, it's all right. Okay, hi everyone. Welcome to the Blueprint Hackathon. Thank you guys all for joining us this early morning. We hope you all really love the learnathon, especially everyone in the hardware track, but also everyone else as well. But today is the hackathon day, and this is the day where it gets really exciting. It's a day of fun, creative exploration and building. So get ready to be on the grind and invent something new in 8 hours. Every year, we're really impressed by the projects that we see and gratified by everyone's openness to learning and collaboration. We're sure today will be no different. With that said, we just have a few details to cover before we begin. And just remember that you can always go to guide.hackmit.org where you can find helpful links and any information you need during the day.
Now, how will today work? Once hacking starts, you should first find your team. If you don't have a team, you go to the help desk over there and we'll help you find a team as soon as possible. Next, claim a table by going to the numbered tables. This will help us find you during mentoring and judging. That being said, please remember that you cannot leave the 6th floor of the media lab. This is a strict rule, given that we want to keep everyone safe and accounted for. We have 3 rooms for you guys to hack in, and the map will both be on the screen later and at guide.hackmit.org.
After finding your team and table, please decide on a division between beginner and general. Beginners are defined as having less than 1 year of experience of coding, and any beginner team must be made up of a majority of beginners. Once your team, table, and division have been figured out, you can then begin working on a project of your choice. Please make sure to submit your project by 5:30 p.m. as that is the submission deadline, and then your project will be judged for prizes. You'll present to multiple judges, and your project will be judged on originality and innovation, technology, learning, and collaboration.
Here's a basic overview of the schedule for today's hackathon. So we're going to start hacking at 8:30 sharp, or as soon as this ceremony ends. Lunch will be served from 12:30 to 1:30, and you have to submit your project by 5:30 p.m. if you want it to be judged. Dinner will be provided today from 5:30 to 7, and we aim to have closing ceremony at 7:30 to 8:30 and get you guys out of here by 8:30. This is going to be super fun as we celebrate the best projects and the winners will be invited to demo their projects, so get really hyped.
We'll also have a lot of mini events throughout the day. First up, we'll have Tetris, where you can live out your dreams of playing the classic game on the big screen. We'll also have a panel where MIT students, also our very own Blueprint organizers, will answer questions about almost everything, from applying to MIT to general student life. Additionally, we'll have cool stuff like a campus excursion or tour, cookie decorating, and more. For every mini event you go to, you'll get an entry into a raffle for something really cool. Not to mention, there will be prizes for our Tetris tournament. We'll also have a Git and terminal workshop, which will teach you all the important things you need to know about collaborating through Git. We highly recommend you attend, as you may even learn new things, even if you have some experience. This is going to be slightly pushed back just due to the pushback schedule in general, but it should be following the opening ceremony. If you want to go anywhere, you can refer to this floor map, also linked on guide.hackmit.edu. Once again, please do not leave the 6th floor by yourself. If you must go somewhere, ask the help desk first. If you leave the building, you will not be able to come back without a HackMIT staff member. For any technical questions, you have a few options. First, you can ask us in the Discord server, but you can also
use our mentor queue at help.hackmit.org. It has MIT undergrads, grad students, local college students, and industry professionals that are willing to help you out. Everyone should save this link right now. You're going to need it. For Wi-Fi, we'll be again using the Wi-Fi setup we did yesterday. So please join the Wi-Fi with the label MIT. And if you need to enter a passcode, you can either use the passphrase you had yesterday or check announcements in Discord for a doc with Wi-Fi information. For any Arduino-related hardware and laptop rentals, you should refer to the help desk to borrow the relevant items. Also, come to us if you have any questions about things you know.
Above all, though, we want to make sure that you all stay safe. So please take a moment to put these numbers into your phones. In case of any issues, your first resource should be the Discord hotline. But in case of true emergencies, you can call MIT Police at the number on the slide. And they're basically the 911 for MIT campus. Like, they'll respond quicker than 911 if you're on MIT campus. Have fun, but please stay safe and don't catch anything on fire. And we still generally recommend that you tend to ask people with staff. If you see anyone wearing like these types of shirts and like a staff badge, please just reach out to them for any questions that you have. And anything else that you can't find, please always just go to the help desk directly.
We'd also like to once again remind you about our code of conduct, which you can get. Please be respectful, as this is a hackathon, and we've outlined all expectations in a document that's linked up there. Yeah, we'd like to emphasize that you must use only things that have been that you had once you start and written during the hackathon. So nothing you use can be made before 8:30 today. You can import open source libraries, but you can't use any code that you've written outside of the hackathon.
Now, with the logistics out of the way, it's time to get into the mood of making things. To start off, we'll hear from Professor Shen Shen, or Shen Square. Shen Shen is a lecturer in the Department of Electrical Engineering and Computer Science, or EECS, here at MIT. Previously, she was a lecturer and a postdoc at Princeton University and then at MIT. She completed her PhD and SM in EECS at MIT, working on optimization and robotics and educational tech, respectively. She teaches multiple learning courses at MIT, including one that I and many other members of the team are in. So we all are super interested to hear what she has to say today. And let's all give her a really warm welcome for her talk.
Hi, thanks for the invite and thanks for the introduction. So my talk is titled Robotics and Generative AI. I think it's already mentioned of my background, but interestingly, I actually did part of my master's thesis on the 3rd floor in this building, although most of the administrative or academic background was still from EECS, so it's on the other side of the campus. So, okay, I'm gonna very briefly, I think we only got like 10 or 15 minutes of time budget. I'm gonna very briefly talk a little bit about robotics and generative AI, and then maybe tie that a little bit back to the hackathon or the spirit of, the making culture. We've already mentioned what do I do. Of course, I nowadays mostly teach, and even more specifically, I mostly teach machine learning classes. At various scale or at various college level or like a grad school level. Okay, I still do a little bit of research on the side. One of the benefit of being a full-time teaching staff is that I don't have to do research if I don't want to. So I think that kind of gives you a little bit of a, I don't know, some of you might be interested in pursuing an academic life or, a professorship down the lane, but this could be another option that you can put in your array of ideas. Okay, a little bit of service, and then most of the time, actually, if I don't have to do any of the above, I would personally prefer to just, go to GitHub, look for fun project repo, and then hack or code for fun. Before I talk about robotics, I think maybe let me hit the second key phrase in the title, which is generative AI. We actually, when we teach classes, we nowadays, as teaching staff, oftentimes would struggle to, suggest or guide students in terms of how should we use generative AI. And, as someone who on a daily basis benefit from generative AI, I think I don't want to be hypocrite. I don't want to say that, generative AI is something that students shouldn't be using. Instead, I think maybe it will be better if we all agree on some sort of a guideline on how do we use generative AI, and then maybe later can appreciate or even funnel back or help out developing generative AI. So personally, I use generative AI still mostly on coding perspective or related to coding. One thing I think many of you might agree with when we write code, right? What we hate the most, documentation. I like to get to the weeds of writing the code that works or that does things, but I don't like writing documentation. Generative AI has been very, very nice for that purpose. Boilerplate code. As you go on for today's hackathon, I imagine some of you might have to achieve certain goals. That's just maybe, a manual bar, or maybe like a submit form or whatever. That's kind of boring, but you have to have that for the purpose of making a project work. The boilerplate code, generative AI is very nice for that. Even learning new programming languages. I remember I learned web development in JavaScript, but nowadays a lot of things are in TypeScript, and TypeScript is just much worse in terms of the syntax. Generative AI has been very, very nice in terms of just getting me very quickly started with understanding the new type of code. And then writing scripts, if we want to do some presentation. Interesting enough, generative AI has been very, very creative in terms of, making connections on things that are seemingly unrelated. And then finally brainstorming hacking ideas if you are still looking for a team or still trying to decide what should you commit to. Now back to the main topic, right? Robotics. So this is our group's entrance 10 years ago in the DARPA Robotics Challenge. Here you might even recognize this big humanoid robot. His name is Atlas. Well, we did pretty well as a group in that challenge. And at the time, if you open up the tech stack and think about how did we control this big robotics system? Well, we used basically physics as a little bit of optimization. So what does that mean? So physics, we've all learned F equals ma, right? It's the Newton's law. But for a big robot like this, when there's a joint, when there's various joints like a rotational joint or a revolute joint, sometimes there's also other types of physics equation that would come into the play. But alas, oftentimes, you can still write down equations that govern the behavior of the robot, and then later math could come in so that you can optimize for some sort of trajectory or torque or force that can be applied to the robot so such that it achieves certain movements that you desire. But you might be wondering, so what are they doing? So these are my lab mates, and well, the reason that they are jumping up and down on the car is not that they are purely for fun. It's mostly because, well, since the equations that govern the robots are coming from math, oftentimes there's a discrepancy between what the math dictates and what the world or what reality actually gives us. So this is more for a robustness measure. At the time, when about 10 years ago, we actually have to compensate or complement the math by some human engineering. This is another example because we want to plan for robot to go certain path. And because we are not so confident in the math itself or in math solely, we have to either try to inject noise in our planner or try to simulate the world as rich as possible, because for things like contact force, friction, or even manufacturer discrepancy that's inherent in the robot system, a lot of the times math itself cannot just capture those things very accurately. So we have to, even almost like a hack in itself, we have to complement the math with a lot of additional tools. Nowadays, though, if you take a look at the progression of Atlas, so this is Atlas 2.0. Well, you see that compared to 10 years ago, the progression is just so impressive, right? So now the movement is less careful. It's able to make much richer contact with the world and doing a lot of more stunts more confidently. And a lot of it is because of the advancement of generative AI. So math has been developing on the side, but then generative AI has also, so a lot of it is also because of how generative AI nowadays is sweeping over all the ingredients or components that would happen along a robotics planning pipeline. Maybe quickly, right? So it's just for fun. But then, of course, some part of that, what I just showed, Intel, right? It's from Boston Dynamics. It's a company. A lot of it is for the PR purposes, that we're making robots dance or doing all of those fun locomotion. But along the way, the people are also trying to incorporate generative AI so that it's more useful for more unstructured environments. So things like your kitchen sink, things like reasoning about how to load various items into a dishwasher. So all of this, if you now think back into the old way of doing robotics, which involves writing down governing equations, describing the behavior, describing the physics of the objects, it's going to be such a pain to write down, how does a plate move if I apply certain force, especially if I don't really know if the plate has, say, greasy leftover from the meal. I also don't probably have a nice way of thinking about what's going to appear in my kitchen sink table or this bin here. So a lot of this nowadays are data-driven or machine learning powered. And in particular, what's involved in this new line of work is, while people go and collect a bunch of data on the internet, trying to reason out a system such that, whereas previously we would rely on math and filling the table by human intelligence, such that we know, when this is the input, what should be the output. Nowadays, it's very much collecting a bunch of data, and then we turn a bunch of knobs in the so-called neural networks, such that while we can intelligently back out or reverse engineer out a system that can achieve certain goals without as much of a human intervention or reverse engineering or manual adjustment. This nowadays is pretty standard, right? You can even download a machine learning library from GitHub, whereby you can just put in an image, and then you'll be able to just tell you, hey, what is the thing on the image, which started from like almost 10 years ago as well. It's also been used for things like the Hackathon, or I cannot even say that word. It's basically why you oftentimes are asked to judge if a thing is whatever is the title says, while implicitly you're actually helping out a lot of machine learning systems by labeling the image for whatever website is paying for the service that you're using. Nowadays, maybe let me skip transfer learning and then talk about generative AI. So since the progression from human filling in the number to machine learning systems trying to back out the number, nowadays all the rage is about generative AI. And if you think about sort of the hierarchy from human intelligence to a lot of memorization or a lot of training to generative AI, it also follows our general pipeline of how do we, as humans, progress in our intelligence pipeline, right? So we first memorize a lot of facts, maybe even against our own will. I remember when I was a kid, I don't like memorizing a lot of like the math multiplication table, the chemistry equations. But then because of all the memorization, somehow along the way, maybe because of random noise or because you met someone and then they inspired you, all of those foundations are going to help us being able to create or generalize from what we've learned previously. And while the generative AI is pretty much the same idea, well, it follows this so-called self-supervised learning paradigm, whereby all the chatbots or all the generative AI systems that you can think of basically follow this way of creating itself. You've all used emails or autocomplete. Right, so if you type on something to the computer oftentimes will suggest to you what's going to be the next character, what's going to be the next word. Oftentimes, it gets things correctly, especially if you use the system for many times before. And how does the paradigm work is, well, it's building on this belief that we've all taken exam questions before. So think about previously the machine learning system is kind of doing a multiple choice question, right? So you're given some sort of image and then you're just trying to predict what's on that image. It's kind of like choosing between cats or dogs or mouse. Whereas now the paradigm shifts a little bit in terms of maybe now let me just scrape the internet for a lot of abundant amount of text, just plain text. And let me hide away part of what's in that text and then force the machine learning system to try to learn a way to predict what's missing. So you can think of this as sort of, an open question in the exam or maybe some sort of an open response or a reading comprehension type of question. And the hope is that if the machine learning system really understood the system or understood the context or syntax of the text, it should be able to fill in the blank. It's kind of a filling in the blank kind of idea, whereby we'd be able to generate or predict what should appear in the missing blank. So the same idea has been applied for images, whereby you've used DALL-E maybe, right? So maybe in 2022, a prompt would generate something like this. And nowadays, maybe a prompt that can be longer would generate something that looks a little bit more refined. Image that I probably personally wouldn't dare to attempt to draw. So the whole idea is, again, the generative AI system has been fed with a lot of just random images on the internet, random text on the internet, forced to try to create parts of the image from parts of the text and vice versa. And the same idea has also been, and the underlying, if you're interested, you can read more, the underlying pipeline or underlying tech stack involved in creating those models is the so-called diffusion models. So along the same line, generative AI has also been funneling back to help out robotics. In particular, so what's shown here is that, by creating this sort of disturbed trajectories for the robot and then trying to force it to come up with the middle points or come up with the planning history that can fill in the blank, we actually are able to now deploy robots that can do more refined, much more refined and nuanced manipulation. Right? So if you think about, again, calling back to the old days of how do we do robotics, it's very hard to imagine that we can write down governing equations that can talk about, how is the page going to respond to a certain force? how is the peanut butter gonna form if I, spread it this way or that way? But then from watching many, many hours of people doing that and then analyzing the video stream of peanut butter spreading and filling in the missing piece, we're actually able to generate using pure machine learning pipeline, generate motions from those histories. Okay, so well, let me maybe skip this part. All right, so I want to maybe talk a little bit about what's, if you love robotics and if you are thinking about getting into robotics, what should you do, or what some good ideas, I think, personally, right? What should we do right now? Programming. I think now that you are all in the hackathon, presumably you all love programming, or maybe you hate it, you just want, make something better so that you can, replace the thing you hate. Which is all totally legit as well. I hate a lot of stuff that I'm forced to use as well. But programming is going to be a fundamental skill for not only robotics, for anything that's engineering, right? So physics, math, I think, especially some of you might be taking AP classes, some of you might be taking intro level calculus class, linear algebra. Maybe I will even throw in probability on this array. I think those are the three fundamental pillars for a lot of engineering careers. And then finally, machine learning, of course. And on that note, if you are thinking about, machine learning, well, I'm teaching this class. A lot of the materials, by the way, this is a song, and this is a song that's generated by generative AI. You can listen to the song offline, but I just want to show that a lot of our course materials, the lectures, the lecture notes, the videos are all on this website. That's for machine learning, and if you are interested in pursuing robotics in particular, these are my advisors class. I might also teach that in some future semesters. So under-actuated robotics and robotic manipulation, both are wonderful classes. They are actually how I got started in robotics, and all of those resources are open online. So check them out, and I hope that I'm on time. I hope that you can all have fun in today's hackathon. Thank you.
Awesome. Thank you so much, Professor Shan. So we're gonna briefly
Not too bad, huh?
we're gonna briefly discuss how to get the most out of today. And you could consider what you can accomplish when you're learning, building, or meeting new people. But we also have a lot of really fun activities that you should definitely consider participating in. Obviously, we want you to have fun building your projects, as that's like the main point of this hackathon. But we also have a lot of mini events and workshops that you should definitely attend, and they're gonna be really useful and a really good way to kind of take a break from all the hacking.
Yes. So one thing you might be wondering is the prizes. So we have a lot of exciting prizes lined up for both our general and beginner prizes. You can see a preview of what some of these might look like on here and on guide.hackmit.org. Yeah. The submission deadline for both the projects and the memes will be at 5:30. So just be like absolutely clear about that, even despite some of the delays we had with practice, just and ensure that your projects are 100% submitted by 5:30 p.m. You can find a guide on how to submit your project at hackmit.org, or go guide.hackmit.org. Everything is on guide.hackmit.org. This will all, and the memes submissions will be on the memes channel on the Discord. After the projects have been submitted, we will have a short break and then judging will begin at 6. We will explain the judging logistics closer to judging time, but know that we will begin at 6 p.m. sharp. So please be waiting at your table on time.
With that being said, hacking starts now. A reminder that the Git workshop is going to be happening, and good luck to everyone. Get a table for your team and begin your project.
Feel free to like, oh, I can share it. Oh, that's right. Oh, yeah,
You know where we can get our dinos? Oh, yeah, it's down there to the right.